Hello students, welcome to another session of this application of derivatives. And in the last session we discussed exercise 6.15 problems and ಅದನ್ನೇ ಕಂಟಿನ್ಯೂ ಮಾಡೋಣ. So exercise 6.1 ನಲ್ಲಿ question number 6 we will begin. ಇಲ್ಲಿ ಏನಿದೆ ನೋಡಿ, the radius of a circle is increasing at the rate of 0.7 centimeter per second. So immediately you have to write ಯಾವುದು ರೇಟ್ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತಾ ಇದೆ, ರೇಡಿಯಸ್ದು. So you are given, if r is the radius, so you are given ತಕ್ಷಣ ಬರಿಬೇಕು dr by dt is increasing ಅಂದ್ರೆ ಪ್ಲಸ್ ತಗೊಂಡು 0.7 centimeter per second. Radius of a circle is increasing at the rate of 0.7 centimeter. ಏನ್ ಕೇಳಿದ್ದಾರೆ, what is the rate of increase of its circumference? Circumference ಅಂತಂದ್ರೆ ಸುತ್ತಳತೆ. Okay, so if this is your circle, okay, so circumference means the length of this outer edge. ಇಲ್ಲಿ ಕಟ್ ಮಾಡಿ ಇದನ್ನ ಎಕ್ಸ್ಟೆಂಡ್ ಮಾಡಿದ್ರೆ ನಿಮಗೆ ಈ ತರ ಒಂದು ಲೈನ್ ಬರುತ್ತೆ. ಈ ಸರ್ಕಲ್ ಅನ್ನ ಕಟ್ ಮಾಡಿದ್ರೆ, ಅದನ್ನ ಎಕ್ಸ್ಟೆಂಡ್ ಮಾಡಿದ್ರೆ, ಕಟ್ ಮಾಡಿ ಬಿಡಿಸಿದ್ರೆ ಯು ವಿಲ್ ಗೆಟ್ ದಿಸ್ ಲೆಂತ್. ಈ ಲೆಂತ್ ನೇ ಸರ್ಕಂಫರೆನ್ಸ್ ಅಂತ ಕರೀತಾರೆ. ಅದರ ಫಾರ್ಮುಲಾನು ಗೊತ್ತಿದೆ. ಸರ್ಕಂಫರೆನ್ಸ್ ಆಫ್ ಅ ಸರ್ಕಲ್ ಈಸ್ 2 pi r. Circumference of circle is given by c is equal to 2 pi r. ಇದು ಗೊತ್ತಿರಬೇಕು ನಿಮಗೆ. ಏನು ಫೈಂಡ್ ಔಟ್ ಮಾಡಿದ್ದಾರೆ, ವಾಟ್ ಈಸ್ ದ ಇನ್ಕ್ರೀಸ್ ಆಫ್ ಇಟ್ಸ್ ಸರ್ಕಂಫರೆನ್ಸ್ ಅಂದ್ರೆ ಏನು ಕೇಳಿದರೆ, dc by dt is equal to how much? Okay, to find, better you write this. Circumference ಅಂತಂದ್ರೆ c is equal to 2 pi r to find dc by dt. So very simple, this is your equation 1. ಇದನ್ನ ಡಿಫರೆನ್ಶಿಯೇಟ್ ಮಾಡಿ, ಡಿಫರೆನ್ಶಿಯೇಟ್ 1 with respect to t. ನೇರವಾಗಿ ಡಿಫರೆನ್ಶಿಯೇಟ್ ಮಾಡಿದ್ರೆ you will get the result. So what is the derivative of c with respect to t means dc by dt equals to 2 pi. 2 pi is constant and derivative of r with respect to t. R is a variable. So it is dr by dt. Okay. So substitute your dr by dt as 0.7. You are given radius is increasing at the rate of 0.7. So substitute ಮಾಡಿ, calculate this. 2 into 0.7 is 1.4 pi and c is the length. Okay, circumference itself is means length. Its unit is centimeter. So you can write centimeter per second. So circumference is increasing at the rate of 1.4 pi centimeter per second. Now here, the length x of a rectangle is decreasing at the rate of 5 centimeter per minute. Decreasing. Okay, negative rate we have. And the width y is increasing at the rate of 4 centimeter per minute. So one increasing ide, one decreasing ide. Okay. Now you have to calculate, when x is 8 centimeter and y is 6 centimeter, find the rates of change of perimeter and the area of rectangle. Okay. So this is your rectangle. Assume that this is your rectangle. And suppose its length is, suppose if you take length as x and width as y, its area is given by length into breadth, that is x into y, or L into B, whatever you take. Okay. Now perimeter. Perimeter means sum of all the sides. Sum of all the sides means there are 2x, this is your x and this is your y. Okay. So perimeter means sum of all the four sides means 2x plus 2y. Okay. So as I mentioned in the figure, no need to explain, length is x and width is y. Okay. So what is given? The length x of a rectangle is decreasing. So given. So length of x of a rectangle is decreasing means you are given dx by dt negative, because it is decreasing, negative 5 centimeter per second per minute. Okay. You are also given y is increasing at the rate of 4 centimeter. So y is increasing, dy by dt is given. Dy by dt is increasing means positive 4 centimeter per minute. What is asked? The rate of change of perimeter and area of rectangle. Okay. So let P be the perimeter. Let the perimeter P is equal to, perimeter is sum of all the sides. So it is 2x plus 2y. And area of rectangle. Area of rectangle is A is equal to length into breadth, that is x into y. Okay. Now you are asked the rate of change of perimeter and rate of change of area. Okay. To find, or directly you can differentiate. Now P is equal to 2x plus 2y. Differentiate with respect to t. Okay, what we will get? dp by dt. This is the rate of change of perimeter. 2 into derivative of with respect to t can be written as dx by dt, and derivative of y with respect to t is written as dy by dt. Okay. So substitute your given rates. Length is decreasing at the rate of, your length is decreasing at the rate of 5 centimeter per minute. So you can write minus 5, and 2 into width is increasing at the rate of 4. Okay, here. So substitute that. So minus 10 plus 8, which is equals to, it is minus 2 centimeter per minute. So here the perimeter is decreasing at the rate of 2 centimeter per minute. So you are asked rate of change of perimeter. So you can write the perimeter is decreasing at the rate of 2 centimeter per minute. Okay. Similarly, you are supposed to find what is rate of change of area of rectangle. Okay. Now see here, area A is equal to x into y, length into breadth. Okay. So differentiate with respect to t. So dA by dt equals to, now we need to apply product rule. Okay, so first x as it is, derivative of y with respect to t, dy by dt, plus y as it is, derivative of x with respect to t, dx by dt. Now you have to substitute the given rates as well as x and y you are given. You are asked the rates at these points. Look at the question. You are asked the rates when x is 8 and y is 6 centimeter. Okay. Now put x is equals to 8, y is equal to 6, and your dy by dt and dx by dt. So you will get 8 into dy by dt is 4, y is 6, and dx by dt is minus 5. Okay, you are given rates. So 32 minus 30, this is 2 centimeter square per minute. So area is increasing at the rate of 2 centimeter square per minute, whereas the perimeter was decreasing. So this is your required result. Let's have one more question. This is question number 8. A balloon which always remains spherical on inflation is being inflated by pumping in 900 cubic centimeters of gas per second. Find the rate at which the radius of the balloon increases when the radius is 15 centimeter. Okay, so understand this. This is your spherical balloon. So what happens on inflation? ಇದರಲ್ಲಿ ಗಾಳಿ ಹಾಕಿದಾಗ ಇದರ ವಾಲ್ಯೂಮ್ ಏನಾಗುತ್ತೆ? ಚೇಂಜ್ ಆಗುತ್ತೆ. ಓಕೆ, ಸೊ ವಾಟ್ ಇಟ್ ಇಸ್ ಗಿವನ್, ಇದರಲ್ಲಿ ಏರ್ ಫಿಲ್ ಮಾಡ್ತಾ ಇದ್ದಾರೆ. ಯಾವ ರೇಟ್ ಅಲ್ಲಿ 900 ಕ್ಯೂಬಿಕ್ ಏರ್ ಪಂಪ್ ಮಾಡ್ತಾ ಇದ್ದಾರೆ? at the rate of 900 cubic centimeters of gas per second. ಅಂದ್ರೆ ವಾಲ್ಯೂಮ್ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತಾ ಇದೆ ಇದರದು. ಯಾವ ರೇಟ್ ಅಲ್ಲಿ? 900 cubic centimeters per second. ಸೊ ಈ ಸ್ಪಿಯರ್ದು ಅಂದ್ರೆ ಸ್ಪೆರಿಕಲ್ ಶೇಪ್ ಬಲೂನ್ ಇದೆ, ಈ ಬಲೂನ್ದು ವಾಲ್ಯೂಮ್ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತಾ ಇದೆ. ಸೊ ಇಟ್ ಇಸ್ ಗಿವನ್ that if V is the volume of this spherical balloon and it is given that its volume is increasing at the rate 900 cubic centimeter per second. So centimeter cube per second. This is your given. Now you are asked find the rate at which the radius of the balloon is increases when the radius is 15 centimeter. So you have to find at what rate the radius is increasing when r is means when the balloon reaches of radius 15 centimeter, when r is 15 centimeter. So you have to find the value of dr by dt when r is 15. Okay, so r is the radius here. So better you draw this figure, then no need to explanation. So this is your r. Okay, now we are concerned with volume. Okay, so volume of sphere or spherical balloon, whatever you write, balloon is in the form of sphere. So volume of sphere is, you must know this, 4 by 3 pi r cube. If you don't know this, then it is impossible to solve this. So volume of sphere is V is equal to 4 by 3 pi r cube. Okay, now differentiate because we want or we are given dv by dt. Okay. Differentiate with respect to t. So dv by dt equals to 4 by 3 pi constant and derivative of r cube, like how derivative of x cube is 3x square, here it is 3r square, but you are differentiating with respect to t means ये r the derivative पुनः बरीಬೇಕಾಗುತ್ತೆ, that is dr by dt. Okay, you need to write the derivative of r, that is dr by dt. Okay, simplify this, 3 may cancel and you are given dv by dt. dv by dt given as 900. So substitute here. So this implies 900 equals to 4 pi r square into dr by dt. Okay, now we are interested in dr by dt. Okay, so this implies dr by dt is equals to 900 divided by 4 pi into r square. You bring this down. Now find dr by dt when radius reaches 15 centimeter. So put r is equal to 15. Okay. So which is equals to 900 by 4 pi into 15 square. This is your dr by dt. So this is 900 divided by 4 pi into square of 15 is 225. It's left to you how you can now simplify. 900 divided by 4 into 225, you will get 900 pi. Okay, so which remains 1 by pi. So centimeter per second. So at this rate, the volume, the radius of that spherical balloon is increasing. So let's have another example. Now see here, a balloon which always remains spherical has a variable radius. Find the rate at which its volume is increasing with the radius when the later is 10 centimeter, means when the radius is 10 centimeter. One thing to be noted, you are asked find the rate at which volume is increasing with the radius, means with respect to radius you are asked. Okay, so you are asked dv by dr, rate of change of volume with respect to radius is asked. Okay, so this is your balloon, r is the radius. So it is very simple to find what? You have to find dv by dt, where is v is the volume with respect to radius. You are asked find the rate at which the volume is increasing with the radius, means dv by dr is how much when the later is 10 centimeter, means when our radius is 10 centimeter. Okay, so you start with volume of sphere or spherical balloon. Okay, so V is equals to 4 by 3 pi r cube. Now see here, this is important thing. We are asked dv by dr. So differentiate not with respect to t, differentiate with respect to r. This is important. Differentiate with respect to r. Okay. So dv by dr is equals to 4 by 3 pi as a constant. This is all constant. Now differentiate r cube with respect to r. So this is 3r square. Okay. Because you are differentiating with respect to r. So derivative of r cube is 3r square. Now 3 cancels. 4 pi into r square. Now you are asked rate of change of volume when radius is 10. This when radius is 10. Okay. So put r is equal to 10. So I will get 4 pi into 10 square. So dv by dr is 100 into 4 is 400 pi centimeter cube per centimeter. Okay. Right. Let's have one more last example of this session. And it will be important also. Look at this. A ladder 5 meter long is leaning against a wall. So let us try to understand. This is your wall and there is one ladder. This is your ground. Okay. Now ಏನಿದೆ ಒಂದು ladder ಗೋಡೆಗೆ ಓರಲ್ ಆಗಿ ನಿಲ್ಲಿಸಿದ್ದಾರೆ. Okay, so this is your ladder. Its length is given as 5 meter. So 5 meter is the length of this ladder. Okay, this is your wall. This is your ground. Further, the bottom of the ladder is pulled along the ground away from the wall at the rate of 2 cm per second. So, ಈ ladder ಅನ್ನ ಈ ವಾಲ್ ಇಂದ ಈ ಕಡೆ pull ಮಾಡಿದ್ದಾರೆ along the ground. ಯಾವ ರೇಟ್ ಅಲ್ಲಿ 2 cm per second. Okay. So the ladder is pulled. The bottom of the ladder is pulled at this rate from the wall. How fast is its height on the wall decreasing when the foot of the ladder is 4 meter away from the wall? Okay. So ಇಲ್ಲಿಂದ ಈ ಕಡೆ ಇದು 4 meter reach ಆದಾಗ when you pull this ladder away from the wall 4 meter ಆದಾಗ so ಈ ladder ಎಷ್ಟು ಡಿಕ್ರೀಸ್ ಆಗ್ತಾ ಇದೆ ಈ ಪಾಯಿಂಟ್ ಯಾವ ರೇಟ್ ಅಲ್ಲಿ ಡಿಕ್ರೀಸ್ ಆಗ್ತಾ ಇದೆ ಅನ್ನೋದನ್ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕಾಗಿದೆ. ಓಕೆ, ಸೊ ಲೆಟ್ ಅಸ್ ಕಾಲ್ ದಟ್ ದ ಡಿಸ್ಟೆನ್ಸ್ ಬಿಟ್ವೀನ್ ದ ಫೂಟ್ ಆಫ್ ದ ಲ್ಯಾಡರ್ ಅಂಡ್ ದ ವಾಲ್ ಈಸ್ ಎಕ್ಸ್ ಮೀಟರ್. ಇದನ್ನ ಎಕ್ಸ್ ಮೀಟರ್ ಅಂತ ಅನ್ಕೊಳ್ಳೋಣ. ಓಕೆ, ಸೊ ದಿಸ್ ಯುವರ್ ಎಕ್ಸ್ ಮೀಟರ್ ಅಂಡ್ the distance between the ground and the point on the wall where the top or the ladder touches the wall as a y meter. Let us assume that this is your x and this is your y. Now what you are supposed to find? You are supposed to find at what rate, okay, this y is changing when x is 4 meter. So better you write. So this is your figure. No explanation is required. Y means this distance and x means this. Okay, so better directly write to find dy by dt when x is 4 meter. Okay, this you need to find. Now you need expression for y. Very simple. If you know Pythagoras theorem, you can apply that for this triangle. Okay, by Pythagoras theorem, okay, what will get? X square plus y square is equals to 5 square. As you all know, this is a right angle triangle, so x square plus y square is equal to 5 square. This implies y square is equals to 25 minus x square. We are interested in dy by dt, so y is equals to square root of 25 minus x square. Don't write plus or minus because y is a length, so it is always used to be positive, so take only positive value. Y is equal to 25 square root of 25 minus x square. Now differentiate with respect to t. So dy by dt is equals to, okay, so derivative of root is its composite 1 by square root of 25 minus x square into d by dt of inside function. Inside what we have? 25 minus x square. So which is equals to 1 by 2 into root of 25 minus x square into derivative of 25 is 0 into derivative of x square is 2x, and further derivative of x is dx by dt, because you are differentiating with respect to t, so it is dx by dt. Okay, so 2 cancels, minus x divided by square root of 25 minus x square into dx by dt. Okay, so now look at this. What is dx by dt? It is the rate of change of your this length. Okay, and it is also given that, better you write what is given. In the given thing only you can write dx by dt. Okay, so it is given that it is pulled at the rate of 2 centimeter per second. So dx by dt is given as 2 centimeter per second. So substitute that 2 here. Put x is equals to 4 and dx by dt is equals to 2, because you are asked this at what rate this is increasing, this is decreasing when x reaches 4 meter. So you have to put these values. So minus 4 divided by square root of 25 minus 4 square is 9, sorry 16, 4 square is 16 into dx by dt is 2. Simplify it, minus 8 divided by, this is 25, so 25 minus 16 is root 9, so this is minus 8 by 3. This is your dy by dt. So y is decreasing at the rate of minus 8 by 3. Okay, centimeter per second. Okay, so this is all about application of derivatives of 6.1. There are few more examples. We will do it in the one more session. So take care.